So in this video, I want to talk about the absolute maximum and minimum value for a function. And when we're talking about the absolute maximum and minimum value, what we're talking about is for a particular graph, if we had a function, like I've got drawn here, what is its maximum and minimum y value, the f of x value? So for this particular point here, is f of x value is at this height, this height, this height, this height. And so what you're looking for this particular value, there is a maximum value there, but it also has, over at this end, a maximum value as well. So we're looking at which of those is the maximums of the maximums. And the maximum of the maximum is the absolute maximum. And so what we've got on our graph here is we've got a local max and a local minimum. And we also have an absolute max here, an absolute max, because the y value for this point is this value, is this value here. And the y value for the local maximum is slightly below it. And if we look at the local minimum, our y value for the local minimum is here. And finally, if we look at the end point as a minimum, this value here is the minimum, and this value here is the maximum, the absolute maximum and the absolute minimum. So if a function has endpoints, so it has a restricted domain, the endpoints, as in this case here, may also be a maximum or a minimum point. So to find an absolute maximum or an absolute minimum, you need to identify all stationary points. So you need to solve dy dx. Let's have a look here. So solve dy dx equal to 0, then substitute into f of x to find your coordinates of your stationary point here. So you might find that you've got 1 at x is equal to a and 1 at x is equal to b. And then what you need to do is also identify any endpoints that you've got and substitute those endpoints here. Substitute those endpoints into f of x to give you their coordinates here. And then you do exactly what I did before and you compare all of the f of x values. You compare all of the y values. The largest is the absolute maximum and the smallest is the absolute minimum. Now your CAS will do a maximum and a minimum value for a function for you using fmax and fmin. So to access that, either on your Scratch, I've used a Scratch pad here, it works on a Scratch pad, it'll work in a document, you go menu and it's under calculus and it's either function maximum or function minimum. And you need to know the syntax to use here because it doesn't actually put up a menu for you to fill it in. And so the syntax that you use, what you use is you take your equation, it'll be something like y is equal to or f of x is equal to, and you put the expression on the right hand side in. Then you put a comma, then you put the variable that you're using for the function. So in this case, the variable is x, so we put comma x. And then we include the two endpoints of the domain, what we call our upper bound and our lower bound. Okay, and what the function spits out, what the calculator spits out, is not the actual maximum value itself, but it tells you when the maximum occurs. So what you then need to do is to take, so for this one here, we know that the maximum occurs when x is equal to 5. So maximum occurs when x is equal to 5. We substitute 5 into our function and we find that f of 5 is 38. Now the 38 is the maximum value, not the x value where it occurs. Now not every function has an absolute maximum and an absolute minimum. So for example, this function here has excluded endpoints. And so there's no clear absolute maximum value. We know that it approaches a particular value, but we don't actually have a maximum value, and we also don't have a minimum value here. And that's the same for if we just take one arm of our hyperbola. Again, we don't have a maximum value here, and that's not because we've got an excluded point on the end, but this tends to infinity, and we don't have a minimum value either, but we have a limit that it's heading towards, which is not the absolute minimum. It's the limit of what the function is reaching. They're two different things.